So that example works like magic, but I know that many of you are asking, hey Polly, how did you pre-generate that pair of E and D such that it works seamlessly from the original data applying encryption function with E? That output applying decryption function with D, we restore back to the original data. You know what? There is a formula behind all these. Okay, given N, how do you generate E and D? And the key, the trick is first to get two very large prime numbers. Let's call them P and Q. That is saying, given P and Q in the formula, and assume there's an end, we generate a pair of E and D. Afterwards, we keep D, the decrypting key, as a secret, of course. We keep also these two large prime numbers secret. On the other hand, we give E and N out to the public. So E here is using the encryption formula as the power. N is used for the mod operator. And here's the formula. Given two very large prime numbers, P and Q. N is computed this way, multiplying P and Q, straightforward. And we compute another number, phi here, by multiplying P minus 1 and Q minus 1. And all we need to do next to find the DE pair is to find such that two numbers after multiplying each other mod phi give us 1. So essentially, DE equals 1 plus multiples of phi. Now, we need to keep D in private. E is out in the public, so people know E. So all we need to do to find D is also what? Given the E, okay, if you can find out phi, then D is what? 1 plus multiple of phi divided by E. So in order to decrypt and to hack, to discover D, one needs to know phi. Now in order to know phi, one needs to know what? P and Q. All right, so P and Q, how do you know? Hey, you can do what? Factorization of number N, which is out in the public. So you see probably why now we need to use two very large prime numbers, because factorization is not that hard unless N is really, 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 really large. Okay, so to factorize a large number remains a computationally intensive problem. It would take probably a long time to solve when N is super large. So it depends on how many bits you're using to generate the N. Okay, the more bits, the harder, the more time it takes. And now you probably know why we said it earlier. P and Q needs to be kept private. If P and Q are public, well, you know also 5, and you quickly solve what D should be given E. So this is RSA, and that's all about RSA.